Hey guys, wait, my microphone's turned the wrong way. There we go. Hey, how is everyone doing tonight? I am doing okay. Preparing for the live stream still. Okay, let's turn the music down. No, wait, that's my normal microphone. That's the wrong slider. Something like this. Let's see how that goes. Where's my chat? Here's my chat. So, wait. Jacco Weiss was first. Am I first? Yes, you were. At least in my chat. Second, lol. Third time to hit like. Good, that's the correct amount. Jacco, thank you. Technically first, but didn't say hi yet. Aye. Am I a bit bright? Maybe. Or maybe it's just right. I don't know. We'll see. Am I 60 FPSing? No. Yes. Now I am. Sometimes the 60 FPS doesn't work. Not sure why. Nigel Young is here. Are we going to have fun tonight? We'll see. We'll see. Are explosions to be expected? No, because I tried to build protections in my circuits. Good evening, everyone, says Medved. Medved made a really cool IKEA drawer mod thingy with an AN Pentamini I just saw. That was awesome. The unmistakable soundtrack. Yes, says Sean. Magic smoke, please. Well, there will be smoke. I'm not sure it'll be magic, though. Time for the rave. Oh, and Johnny Bergdahl is here. Nice. So everyone suddenly got quiet when I started the stream. Oh, hello, Kitty. Kitty said hi. Moo, hey all, and firmer birthday boy Johnny. Wait, was Johnny's birthday? What? Well, congratulations, Johnny Bergdahl. Good evening, says Chris. Let's see. Uh-oh, Kitty is still here. He might become annoying. We'll see. I'm going to drink some lemon Fanta lemony. Yes. What do you want? No, I'm live streaming. Go play in the living room. Show the kitty cat. Then I get all kinds of hair on my desk again, and on me. And my cameras are attached in such a way that I can't really easily move them, so... Oh, I don't love beer pics, Johnny, sorry. Quincat on the store when? Well, I always said if I get 100,000 followers, I'll start doing merch. And we're nearing 60,000, so we're getting there, but it'll be a slow process over the years, I think. Oh, it's Philip and Avenge CJ. Nice. If Andy shows up, like everywhere, lots of people are here. And for my, I can't really judge how loud the stream is. Let me listen to my own stream. Wait. I have to listen while the music is muted. Hold on. There? Yeah, okay, that's too loud. That's too much music. So, okay, this is a new test, and then I can see it for myself like a few seconds later on my own stream. So I'm muting the audio. No, wait, I didn't listen to the music. Okay, so now there was music, and now I'm muting it again. Yeah, okay, that's better. So about minus 25 there. Okay. Anyway, sorry for this technical intermezzo. Oh wait, now I'm still hearing myself. Mute, there. So we're going to build something again today. How's that? Will there be pink PCBs in the stream? Sadly, no. If you order pink PCBs, they take like 3 times as long and they're 3 times as expensive. It's not really financially viable for a prototype. Rual asks, looking around on your website and YouTube for a while now, do you actually have a video where you physically power inject into a string of, let's say, 20 meters of wire? How do you do it? I'm not sure there is a physical video. The power injection video will show where to inject and why, etc. And generally we pick the 5 meter points because then you have the extra little pigtails. And you could just use something as simple as a Wago or something like that to connect it together with the incoming wire. Yeah. So if you want pink PCBs, you need to order a lot of PCBs. Well, that would certainly bring the cost down. Anyway. Wait, what's going on? 100 SEKs from Johnny Bergdahl for the Pink PCB Fund. Also, SEKs rule. Thank you there very much there, Johnny. I can actually hit like and reply. Reply to Johnny Bergdahl's super chat. Yay. Send. How does that look? Huh. Well, I can heart it too. There. What more can I do? There's all kinds of new functions. So there's no soldering needed, and you just use those wires on the cable. Yes, that, ideally, if you can inject at those points, that is absolutely the easiest thing to do. I thought you had to solder them to actually inject. No. You just connect those JSTs together that are in that spot anyway, and then generally it has those extra little wires, and you can use those to power inject. Vin P hasn't been here for a while. Last he saw was 12-volt addressable LEDs. Are there new 5-volt variants? Oh, there's all kinds of stuff going on. Are you looking for something specific? Oh, Draadstahl is here. Well, I can guess we can get the party started then. No, I still have to wait 2 minutes. It's mandatory. It's in the rules. It was more ambient lighting. Okay. Oh, Roal says, I also had a question of the ASP EA Plus mic. It works only with the... no, it should work on even the most recent version there, Roal. Shouldn't be a problem. How about bright RGB WW LED strip? What's WW? Warm white? If you meant dual white, don't ever write that as WW. That's wrong. I know it's done more often, but they're also wrong. If you want RGBW, that's RGB with a white channel. If you want, and then the white can be various colors. And if you want RGB with dual white, you write RGB CCT or plus CCT, depending on if it's in a single package or multiple packages. 60 pixels per meter, 48 volt. What? I don't know if that exists at 48 volt there, Richard. RGB WWCW. Well, that's a stupid way of writing RGB CCT. Sure. At least it's clear what it is, right? RGB W is unclear what you mean. So, Richard, I think you should look into Cobb LED strip, maybe, like the addressable neon, although that's not RGBW. There is an RGBW variant of that right now, but the zones are a bit large. But that is the brightest strip that is currently available, addressable. So, are you looking for analog or digitally addressable? What are you looking for? Off the record, how many LED pixels have you ever tried altogether using the data booster? Well, the data booster doesn't allow more or less LED pixels on a line. It's there to solve a problem. For instance, if you have pixels or a bunch of strip and you need to bridge a 2 meter or 3 meter gap, if you do that with the data signal coming from those pixels or LEDs on the strip, you're likely not going to get very far because they're designed just to go to the next pixel or LED on the strip. But using a data booster, you can easily go 5 to 10 meters. Something caught in my eye. Is there a technical reason why 48 volt addressable LED strips are not available? I would love them for my project. Yes. So 5 volt LED strip is addressable per 1. 12 volt addressable LED strip is addressable per 3. 24 volt is addressable per 6. So 48 volt addressable LED strip would be addressable per 12 LEDs. So you'd have segments like yay big. Because the LED diode voltage doesn't change, so the high voltage needs to be dropped somehow. And you can either do that with a buck converter, like we've seen on those 48 volt pixel pucks, which are like $1.50 a piece. Or you can do that by dropping it over multiple diodes in series. But then thus you need 12 to be able to drop 48 volt. And then there's other problems like the WS chips, etc. They're not 48 volt compatible, yada yada yada. So there's lots of technical reasons why that doesn't exist. Yeah, exactly, Medved. Oh, settling in your new house. Nice, Johnny. So today, I overloaded the microphone. Today we're going to take a look at a project that's been lingering for like 2 years, 3 years now, I don't know how long. And that is a Data Booster Mini. Do I have a Data Booster here? Damn, I should have gotten a normal Data Booster. Let me get a normal Data Booster, hold on. sorry. Couldn't find one. I think it's not the most recent version, but it'll do. Heal, yeah, but then there would be other technical reasons such as heat and other issues that are kind of preventative for that. But the new cob LED strips, they're kind of going that way by using very tiny LEDs. And thus, we already have now 24 volt strips with fairly high resolution, or high resolution at least. And I'm working on a custom version of that, but we're not going to talk about that today. So, this is the data booster in its current form. That's actually not completely true because I've made a new version that is available already, I think. I'm not sure, but it doesn't really change too much. So this one has always been called the Data Booster Maxi. And the reason for that is because I've always had plans to have another one. I never made or released it though. But if we look at this thing can do 5 volt to 48 volt. It has some power injection options here with these pads. And you can use the screw terminals for the wires that go through it. And then it has an LDO for the power, some capacitors and stuff. It has a special level shifter. It's not the same level shifter as is on the dig boards because it's kind of supposed to have a different function. It's a bit too hard and technical to explain, but in the end it does the same function. It level shifts and takes in whatever signals coming in, boosts that and tries to clean it up, and then sends it out of the output again through a resistor. And on this board you can switch it between 33 ohm and 249 ohm to adapt the signal to the type of cable you've connected. Now, I've always had the plan to make a smaller version, and this is a iteration of that. It's not the newest one though. We'll be looking at that shortly. As you can see, it's I still have something in my eyes. It's a lot smaller, as you can see, and today we're going to take a look at the latest version of that. If it's in here. Wait, what? Oh, wait. When your PCBs come in a package this small, I mean... oh, wait, was it the latest version already? No, I think this one has larger holes, doesn't it? And it's slightly longer. Yeah. So, these are the latest version. We'll take 3. So, and this one needs to be this way around. So this is the latest prototype I want to build a few of today. As you can see, it already has the new logo on there, which is pretty cool. And yeah, I want to build 3 of these today. And then I will be doing some testing because there's a slightly new or revised circuit on there. And some other new things. And these could be nice. Instead of having this big bulky module, you could have something that you could easily heat shrink in with glue to make it waterproof, or at least put it in something very small to make it waterproof. And it would still perform the same function basically. No power injection, things like that. But most often I see the data booster used for bridge gapping set to 33R. So I thought, okay, let's make a tiny version, because this is 9.9 millimeters wide, so it's actually the same width as an LED strip. That only does 33R, but does do the gap bridging function, basically, right? So these can go away. Yeah, these are really tiny, but for production that shouldn't be an issue. Now, what is an issue is what you've been looking at this whole time. Because I ordered a stencil, but they clearly didn't listen to my instructions, and they have no intelligence whatsoever. Because it's not a framed stencil, that's even worse. So I know I clicked unframed stencil. Wait. But they sent me this stencil. I mean, nobody there thought like, huh, maybe this stencil's too big. And I'm pretty sure that I set the custom size to the smallest there was, and I don't know what happened. Oh man, I mean, you could fit like 100 of these in this stencil size. It's totally insane. Lots of space to rest your hand on. Compensating much. Yeah. I don't know. Okay, let's get started. We'll make it work. We'll make it work somehow. I don't know how. This thing is way too big. Okay, let's get my board out. Mouse needs to go here. So yeah, my board's way configured wrong. Looks used. Now I don't know what they did. There's tape on there. I don't know why there's tape on there. So let's undo all these. I guess I have to undo them all. We'll make it work. No. It's not thin aluminium. That's the steel stencil. You're not going to be able to cut that easily. So it's on like that. So then like that. Okay. Well, I've tried it before. It absolutely would not work. You think there? Well, this normally I order either from JLC or from PCBWay. This one came from JLC. With PCBWay, I've never had this issue. So maybe they're just, laughing about it. I don't know what's going on. So let's make sure this can't move. I generally like PCBWay more, and depending on what the project is, I order there. But JLC isn't bad. They're just worse than PCB, but not bad. So let's get that tape off. I'm not sure why that tape's on there. But JLC is a lot cheaper, and sometimes faster. Not always, though. They say they're faster, and then they're not. But especially if I'm ordering components to go along with it, it's certainly cheaper because you get some off on the shipping costs. So yeah. So let's see how we can make this work. Wow. Wait, there's also tape on the back? Jesus. Never had tape on there before. Power diff is coming along, but there's lots of stuff that needs to be released currently, so it's slightly halted in development. Not so much because of the power diff, but because of other projects. What the hell? This isn't a thin sheet either. I mean, I can try and cut it. Let me try and cut it, but I don't think it's going to work. So here's my titanium scissors. So it says it right there on the scissors. Well, you can't see, huh? Let's see. No. See? Titanium. So in theory, you'd think the titanium scissors would win from the steel plate, right? So let's give it a try. I've tried it before and then I decided never to do that again. Okay. Maybe Andy had a point. Have to watch out that I don't stab myself with it. Okay. That works. Stencil Maximus, yes. Okay. Not sure where to put this. I don't want to stab myself. Okay, now we have a lot more manageable stencil size. That's good. It's not symmetric, but that doesn't matter, I think. So let's see if we can maneuver this on there. There. I'll show you in a minute. Hold on. Yeah, I need to cut this up a bit more and then dispose of it. One moment. Almost there. Okay, I should be able to dump this. Let's see. Yes, good. Okay. So now we get my my red tape. And let's put it over the top here. Like so. So we can make it a flippy. There. So now we can flip it up and down. Of course it's not straight, so that's a problem now. Okay, a little bit of tape on the bottom. No, we're not making a muizentrappetje. The zoom on the hairs, oh no. I'm having a hard time seeing if it's aligned or not. Hold on, let me... I think that's it. I actually remembered I need to get my paste. So last time we used that AliExpress special paste. We're going to do that again this time. But I put it in the fridge, so let me get it. Here, we have the Melting Point 138C maintenance paste, and if you use it, danger, prolonged death. Death. So, yeah, the death paste. Okay, let's get the tools. I still have normal paste too, but I don't know, it's fun using AliExpress paste for some reason. Okay. So let's mix it up a little bit. Oh, still looks pretty wet. That's good. So let's mix it a little bit in the tub. Guess we could do like that. Okay. Oh, have fun, Johnny, and congratulations again. So let's jot down a bit of paste. We don't really need a lot. Although I do want to do 3 boards in one go. So we'll see. It's a little bit thicker than it was last time, I think, but not by much. Okay. So let's ball that up a little bit. Okay. Let's see how that did. That looks pretty good. All pads are pasted. Okay, 2 more to go. So let's make sure this is aligned. It's completely not aligned. How is that even possible? This way? No. This way? What? Oh, that way. Okay. Let me check that again. Sorry. Nope. That's better. Better, but not great. Oh, nice, Emil. Yeah, you told me about that a little bit. Okay, I'm just gonna go for it like this. This piece is so wet. Let me. Yeah, this paste is definitely a little bit of it. Oh no, it's all over my desk. I was going to say a bit of a challenge, but it's drooping on my desk. Hold on. So let's do the last board real quick. Let's hope this aligns. Nope. Okay, like that. Yeah, don't touch it prolong. Yeah, I know, I remember, but it's now all over my desk. So we're gonna have to clean that up. Let me get what's on here off. Okay, let's close the pot. And then the horror begins. Because, let me make sure these are safe. If you look on my desk. Oh no! It went on the pad. I'll never get that out. We're gonna try, but... Death by solder paste on desk. Exactly. So, okay, I'm going to clean off the board. Then I'm going to remove the board. So this kind of works. So I might be able to use that on the desk too, but there's gunk here. Okay, let me just clean the oh man. So when using this paste, you can't just put it down because it'll drip on your desk, as evidenced by my desk. Exactly, Dutch Taurus. Uh-oh. But I've had that since I've been 12 or whatever, so I haven't been playing with soldering paste for that long, I think. Let's rub it into the wood. My wood might now be conductive, but who knows, right? I didn't know, officer, that my wood was conductive. How did my wood become conductive? Okay, so the board... Okay, I still need to remove this. Okay, clean this. Bear with me here. I know this is boring, but, you know. This is what it's really like. Even if you guys aren't here. Okay. Put that over there. Okay, board can go away. So, let's try and scrape it off. Yeah, that's maximum unzoom. Well, sure, CJ, but solder paste is very conductive. I mean, that's the whole idea. Okay, so I'm going to apply pressure and try and get it onto there. Could have been worse. Could have put that in the jar, I didn't. Okay, let's try it once more. Maybe the other way. Okay. I'm not mad at that. Nobody will ever know. Who will ever know? Nobody will know. Why would they know? Well, you've all been here. If there's a weird spot there in a week or two, you know what it was. Okay. So we stumbled through pasting these three little boards here. Oh yeah, new logo. You're right, Andy. I need to make a new one. I was just looking that way, and that's where all my switches and network stuff and things are, and I just noticed that my 10 gigabit switch came off the wall. It's just hanging there. Oh, it's working. I'll fix that after the stream. So we need some oh, don't touch things. Okay. We need some tweezers. And I think I'm going to put them above each other. The impedance of my desk mat, yes. Nope, other way around. Okay, more cleanup. Hold on. Get this in the box, otherwise I'll lose it and never find it again. Now the box can go there. No, what? Okay, that's okay. Whatever. Right, IBOM file. I don't think I'll be sharing the IBOM file on this one, unless you guys really want me to, because it's not that interesting. Hold on, I just heard some cats screaming. I don't know what's going on. We have a new kitten, and I thought maybe the kitten and Kitty, haha, were going at it. But Kitty is outside, and Kitten cannot go outside. And Kitty is sitting on the lawn like I own the place. So I think another cat came to visit, and Kitty was like, "Well, I own the place." So. Yeah. Let's see, Data Booster Mini. Oh, Phil Bulldog is here, nice. Right, let's take a sip. Okay, Kitty came in loud screaming. I think he defended the yard. Well done. Well done. I'm just gonna go for it. There's not too many components. Did you name your cats? No. There's no Dick Kitty. Oh, right. This office is too small. I need this box. This is under 500,000 other boxes. Okay. We need some 0402 0.1 UFs. And we need 2, so we need 6. So let's see if we can put 6 here. Oh, I put my plank away, but normally I use that for my components. We'll use this random object that is totally not the secret of today. Okay. Nope, didn't place. What are the dimensions of the board? They are 9.9 millimeter by 20 millimeter, so 2 centimeters. I think they're on the right spot. Let me apply some digital zoom for you guys. There, that's better. Okay. Then we need an 040210 UF. In theory, it would fit in a 10 millimeter profile, yes. And I'm not yet sure what height they need to be. So this PCB is 1.6 millimeters, but I can of course use 1.2 or even 1 millimeter. Yeah, these are gonna need some corrections on the microscope later. Okay. Don't think so, Emil Bart. Let's see, capacitor 0805. No. Hi. Oh man, my complete office is a mess. Oh, yep, found it. Let's see, one UF. 0805? Yeah. Are you sure? Yeah. He's still here for some reason. Okay. I think that's all the capacitors. I'm gonna skip ahead because I'm gonna need to find something I know I don't have. So that's always good, right? 60 volts. Okay, this is already a good candidate. No, it's 1206. Okay, I need a different box. Where? Oh, where? Oh, it's over here. Don't do that. So, we have a candidate. This is a better candidate. This is an even better candidate. Yeah, that will do. Yep. There, another part placed. Okay, let's go for the... Oh, I didn't put this back. Oh no. So anyone have any nice plans for the weekend? I'm actually going to a little LAN party with friends tomorrow. It's been a while. Teaching sailing in a gale. What's a gale? Suspect much tea drinking. Nice. Let me fix this one. Tomorrow install, then out for dinner in The Hague, and next day Hackfest in Enschede. Ooh. What's this Hackfest you mentioned? Okay, that's one. And then we need these. It's funny, in the PCB editor you can just zoom in more. In real life, it doesn't really work that way. Oh, okay. Cool. Gale is very strong wind, so no actual sailing, just tea and discussing. What? Oh, it sounds pleasant. I mean, don't get me wrong. You know, there's a worse ways to spend the day, I guess. Okay, so this is done. Oh, I need more resistors, of course. 541K. The magic number. Come on, little resistor. Resistance is futile. Am I now done with resistors? Yes. We are done with the resistors. Okay, we need an LED. The connectors look the connectors look larger than the PCB in plated holes. Yeah, but we're gonna solder some bare wires to that. So we will see. I should have some LEDs here somewhere. Oh, oops. Okay. Let's see. 0603? No, of course not. You went there. 0805? No, too easy. Pink LEDs. Should we do some pink LEDs? Maybe we should. I know Johnny isn't here, but it was his birthday, so we'll do some pink LEDs. They'll probably be too bright, but we'll see. One, two, three. Johnny will look back in the stream and he'll be like, "Aw," or not. Okay, so it's we're gonna do my little multimeter trick again. I need to know what's pin 1. So that's ground. Okay, good. So I'm going to show you the trick So here we have some tiny, tiny LEDs. And one side is positive and one side is negative. Now I know what it is on the PCB, but I don't know what it is on these LEDs. So let's go to continuity mode. I think will be enough. And on the PCB, ground will be on the bottom. So, oh wait, they're on a metal surface. Do you think that's a problem? Wow, those are bright. Okay, this one's the wrong way around. Yeah. Yeah, okay. So now I know they're all oriented correctly to put on here. I moved one. So for that one I don't know anymore, so let's test it. Nope, wrong way around. Yep. Okay, well, as I said, we'll have to look at the microscope in a minute to correctly orient some of this stuff. Yeah, okay. So the LEDs are done. That's often the hardest part. Now we need some ESD diodes, and I hope I already sorted those in my box. But I might not have. Let's see. Where is it again? There's the 05. Yeah, as I thought, these are not in here yet. So most likely they're in this box. We'll have a look. Not yet. Oh, there they are. See, I kind of knew where they were. Let's get 3. Still think we should do some sort of Quinfest. LED installs from different Europeans in one location with one rule: Quinlet driven. Nah, then we should just do like LED Fest, but without professional gear or something like that. Doesn't have to be Quin LED. So now we need to find the correct orientation. Mr. Magnifier comes out again. I need to go ultra magnification. Okay, this one has a stripe here. No. Okay, that's one. Two. And three, and we're almost there. 2 chips left. Yeah, we're gonna have to correct some stuff under the microscope. Okay, we need some LDOs. Let's see, what do we need? The okay, DS. Okay. Yeah. And these are easy to orient because they have 5 legs instead of 6. Nope, all the way around. There. 1 chip left. Trying to see if I stole the box already. Or is this one the other way around? No. They might be in here. They are. Listen. No. Yes. Tiny little buggers, but also 5 legs. Easy. Just need to have the legs on the bottom. Are those the right footprints? I guess so. Chat's kind of quiet tonight. Are you all so mesmerized of me putting components on a board? Is anyone still there? Maybe chat's been disconnected this whole time and I just didn't notice. Just talking to myself. Okay. Oh, Joey's just chilling. Q in the chat. Or Q in chat. Yeah. Okay, I think all components are there. So now let's use the microscope to check it. Okay. Oh, we get my little microscope tower here. Oh. Uh-oh. Don't mess with the microphone connection. One moment. Oh, there it is. Okay. The microphone came back. Good. It's USB too, so I was afraid that if it disconnects, it's gone forever. But it's not. Right. Let's go to the microscope view. Need to turn on power. There. Let me check something real quick. Oh, that's good. Okay, whatever. Let's see here. That's gonna need some corrections. Let's get it nice and close. Yeah, this footprint doesn't seem right, does it? For the level shifter here. I mean, I think it'll work. No, that's not the right footprint. Hold on. Is the ultimate disk project visible with the microscope? Ouch, ouch, ouch. So it should be SOT 23.5, but it's SOT 353. Which one is on here? I think I used the wrong footprint, because if you check here, wait, that is the same footprint, right? That's the same. Is it the same size? Maybe not. No, it's not the same size. Okay. I need to look up if this part can replace it. One moment, please. Yeah, I think this part can replace it for now. Okay, let's do that. This is a disaster. What? Don't worry about it. It's not that bad. Or you mean all the parts? Nah, we'll fix that. Don't worry. So let's get all these tiny little buggers off. And let's put some other types on there. There. I'm going to put the others on real quick and then we'll fix everything that's misaligned. So let's go to this one. Yep. And then let's go to this one. There. Okay, let's fix those little parts there. This one needs to go. Okay.
Think I need an exorcist right now. Oh, hear your voice, but you are not around. Oh, visions of your
That should be fine. This needs to go. Oh no, wait.
left me headed for the coast. Now I'm living with your ghost. I still hear echoes, echoes of you. I still hear echoes that I can't mute. They're haunting my dreams like a playlist of memories. I still hear echoes of you.
Okay. There's a bit too much paste on this one, but that should all fix itself. Let's see here. That's okay.
Left me in my room with
It's
all
okay.
this space. Yeah. Trapped with all the words you used to say. Yeah. How much longer till these fragments fade? Left me headed for the coast. Now I'm living with your ghost. I still hear echoes
That should be fine.
of you. I still hear echoes that I can't mute. They're haunting my dreams like a playlist of memories. I still hear echoes of you.
Okay, that should reflow fine. This big cap is a bit how you doing, but I think it'll be okay. Yeah. This is my my second time with this paste. I think I'm gonna go back to to my normal stuff. Let me make a note real quick that I used a different IC. Okay. Good. So I did have the IC I wanted, just not in the right footprint, or at least not in the footprint I used on the board. Such stuff happens. So let's do some reflow magic. Nope, wrong button. Okay. Thank God for surface tension, yeah. Okay, we have my little 10 by 10 millimeter hot, 10 by 10 centimeter hot plate. Okay. On. Set for 155. So let's get the little boards on there. Let's see. There. Now this is maximum zoom. Yeah, this is maximum zoom. Okay. Just checking out the datasheet for the IC I used. Should be okay. Or maybe not. Let me check another one. I'm actually going to replace them, but we'll do some live replacing while it's on the solder machine. As you can see, all the paste is melting. Come on. Okay. Now this is going to be interesting. First I'll take them off. That's one. 2. And 3. And now I'm going to put them back. I'll take a look at that cap there, Scott. One moment. Why do these ICs always want to lie on their back? No.
They talk about another kind of world. Another kind of...
Okay, one more.
What are you afraid of?
I'm lost in old ways. I'm not afraid.
So those will work, I think. Okay, so oh yeah, this cap needs help. I think that did it. Let's see, those look okay. That looks okay. That looks okay. This could need a nudge. Okay. Okay. Oh, don't want to do that. Yeah, I think that all looks good. Hot swap, exactly. Yeah, I think this one is a better one.
They talk about another kind of world. Another kind of world.
What are you afraid of?
No, this one also isn't great. Damn it.
Lost in old ways. I'm not afraid.
Well, alright. I'll see what they do. I guess I shouldn't leave them on the hot plate. No, okay. I'm gonna replace them again for something I know that works. Otherwise this is useless. Oh. Sorry for this mess. No, wait, wrong ones. I guess I should turn the hot plate on again. I turned it off. Dr. Bibber, yeah. Although I generally tend to have fairly stable hands. No, and I'm not doing the small one. Those are not going to fit. Hold on, let me put this back. There. I think we still have enough temperature so that we can remove these.
It all burned down.
There.
I swore it was for the last time, but here I am now.
A little nudge. Okay, that one's okay. That one pulled itself in place. Yeah, I say that's good enough. Okay. Well, these I know will work. They're not the ideal for this application though, but at least I'll be able to measure something. Okay. So let's get them off the hot plate and check them under the microscope.
Let's pretend and be friends in the dark. Set my body on fire. Worried and
Let's see, microscope beam. Right, so let's see, the top one. So this shifter is a little bit too far down, but I'd say all these pads are making contact, that's no problem. This all looks good. Yeah. Second one. This is a little bit crooked, but still makes contact. This one's all kinds of twisted. But it'll work. Let's see, okay. Yeah. And then the last one's perfect. Yeah, that all looks good. Let me check something here. Let's make sure these are electrically connected, but I think so. Yeah, okay, next. There's still, again, some balls there. Yeah, see, this is crooked, but nothing's touching or bridging or something like that, so that's fine. Same for this one. Okay, well, done with the microscope. The microscope? Yes, it's a microscope today. So now we need to attach some wires to it. Okay. Rate to paste. I'd give it a 4 minus. It's good paste. I mean, you just saw it on the reflow plate. It flows just fine. The only gripe, there's 2 gripes I have with it, and that is that it's too fluidic, or too yeah, it's a bit too fluid. Maybe that's good in some applications, but for my on-desk work, well, you saw the trouble that caused, right? There's more balls after the soldering process than I'm used to with my Chip Quick stuff. So, yeah, but for like the $5 it costs on AliExpress, it's not bad. You can certainly build board with that. Okay, let's reset the cam here. There. And let's get some pigtails. Because I don't know what kind of cables I want to connect to this yet. So on one of them, we're just going to make some male and female JST connectors. No, sorry. There's actually a video that's coming out soon in Third Tom that this has been fixed, but the way it's been fixed is by moving the temperature sensor off board. So you won't be getting a board with a temperature sensor on there anyway, because it's now external, basically. Yeah. So let me think. Normally on a controller, we make... What kind of plug do we make? I think we make this plug on a controller, so it needs to go like that. Let's see. Let's do one. Let's move these away. So yeah, currently on the worldwide and Dr. Z's also already, we're selling the V2 of the brain board, which has some changes, but the video for that will be coming out next week. And I'll be working on the articles and things like that. Now, how we connect this is going to be interesting, because I haven't really figured this out yet. I guess we could do it like this. Right? So we could hook in the wires from the bottom and then solder them in. Or we could do it... from the top, like so, and then solder them in. Now currently the bottom has nothing. The bottom has no, it only has my logo and some little text there. Ah, there. So what do you guys think? Should it go from the top or from the bottom? I'm thinking if you do it this way, from the top down, you'll get solder joints on the bottom, which currently is flat. But if you do it the other way, you get the solder joints on the top, which is nice, but then the cable is on the bottom. So you don't need to insulate the bottom. Top looks nicer. Nice endo baggings. Hope you like them. Yeah, let's try them from the bottom. Yeah, we could also try that. We could also just solder them as if they're pads. I'll need to figure this out for production at some point. Which is mere, yeah. Let me get my soldering on already. And the fuel extractor. Yeah, pads is interesting, but I'll have to figure out the production process for that. But we could try that right now. I guess I should zoom you in more again, huh? Nope. There, that's better to see. So let's just give that a try. I think I'm just gonna tin the pads, and then we're gonna put the wires in there. The idea is to figure that out, CJ. So that's why I'm making some prototypes. Sorry for the extra noise. One pad, one bottom, one top for science. Yeah, maybe. So let's just fill these with solder. Because then they kind of become pads, right? I know everything's pretty close, so that's a problem. Might need to make the pads less long. Oh, my little level shifters are still here. Goodbye. So let's give it a try with the red one. Okay, let's do data. And ground. True. There aren't any other holes in there, so that would save on manufacturing. I just need to see if they can make it like this. But in theory, I'd say if they make a jig, this should work pretty well. So let's do the same on the other side. Let's tin it like... no, let's take a look at how the other side looks. Yeah, currently that's okay. Oh, I'll get one, Rich. We still have the other boards. So let's make sure there's enough there on VCC and okay. Okay, that's oh sorry, hit the microphone. That's pretty good. So far, I don't think we've soldered anything together yet. So let me do this with my oh god. Okay, other hand. There. Let me try and see if I can give you a close-up. No? Yeah. I don't think anything that shouldn't be touching is touching. Because even if this cap would be touching, that side is ground anyway. But it's not. And VCC is safe because it's far away. And even over here with the little diode there, I think that's okay. Yeah, that's not touching. Okay, cool. And down here, well, currently it looks like this. But if we do pads, well, that wouldn't even be needed. And in theory, this is strong enough. So, okay, so someone said, can you get a 10mm strip and see if the pads line up? Now, it's not built for that, I guess I could say. But it's not built for that. So let me get some. Oh wait. So this is some standard WS2812B. Yeah, but then you get extra thickness, Dave. So that's why we didn't want to do that. So let's see. Right. If we align it with the in, so this is the inside, and the arrow goes that way, so that's good. It doesn't perfectly align because the pads. So the width is correct, right? So the board is about the same width as the strip, but I mean it's still board on the side here, and I used all of the board instead of having them too close together, because that would make soldering wires less easy. So these don't exactly line up. Now let me get something else. Yeah, I think this is more of the same. Yeah, these pads are mostly in the same location. Let's get some SK6812. So for 6812, it seems like the pads are slightly further apart, but still it won't align perfectly with the board, because the board's been designed for wires, and then having the extra space is nice. Alright, so I guess that's a design choice. Okay. Now I'm not going to solder up the other ones because there are some testing. The circuit as it is currently on there is likely not going to work, actually, because it's not really designed for that. What I'm going to do with this one is I'm going to solder on some high capacity wire, some 18 gauge, and then just some data wire for testing I want to do. So let's see if I have some 18 gauge or something. What's this? No, I shouldn't use this. Okay. Whoa. What's this? It's falling apart. Yeah, this is this 16 or 18? I think this is 16, right? Yeah, this is 16. Let's see if 16 fits. Maybe, but then the people who would be capable of soldering this in line, would they be the ones buying this board? That's always a bit of the question. So I guess in theory it doesn't matter if they can fit through the hole. I don't think 16 can fit. I think 18 can fit, but I don't think 16 can fit. So let's give it a try. Oh, no, okay, no. We got some spillage here. Yeah, so 18 gauge would fit through the holes, but 16 gauge won't. But can we solder on 16 gauge? I think we could if we really wanted to. Should we try that? We'll try that. Well, I think I'm gonna sell these in multiple forms. Let me get a data wire real quick. So I'll probably sell them with JSTs on there, like we just soldered. And I'll probably also sell them with X-Connect on there. And we could sell them with nothing on there, right? So you just get the bare board, and it's up to you to solder it together. No worries. I mean, I'm thinking I can adjust the board, the spacing on the board, but then it kind of becomes less good for wires because then everything is so close together. I don't really like that. So I'm not in love with that idea. So I'm just taking off a little bit because we don't really need more. See the other one? This one is too long, so I'm going to cut it. It's not straight, but it'll do. We really only need a tiny little bit. Okay, this is too little. Yeah. And this side. Yeah, strips or strings. I mean, we've seen enough cases where even with strings, although those have the bigger chips, it still is a problem sometimes. So I'd like them with oh god, damn it. Well, you try to dump it all in the trash bag and you don't. Okay. But yeah, we can make different versions. I mean, that's pretty easy. It's just soldering on different wires. That's not a problem. Yeah, this wouldn't be for boosting from... I mean, you could abuse them for using them as a level shifter coming directly off of an ESP. The chip I normally use for that is less suited for that. That's why I use different chips on the dig boards. But it generally does work. But I use a different chip for inline gap bridging, because that one is better suited for that because of shifted grounds you have in those places. So initially when I designed the board, I did some testing with that, and I found that for the gap bridging, using a different level shifter worked better than the level shifters I use on the dig boards. But that way everything has its purpose. I mean, that's why different kind of chips exist. You need to find the right one for your application. And bridging a gap in the middle of your LED install is a different application than level shifting from your controller. Oh wait, the data wires. Need data booster diff as well for long bridges. Well, you already have the diff solo and the diff advanced now. So, okay, let's do the pad method again. Oh, you can't see there. So we're going to flood this with solder. On the other side too. Okay. I'm thinking we'll do data first. That looks pretty solid. Okay, that looks pretty solid too. So now let's do positive. This wire is a bit too big for this pad. Oh. Ow, that hurts. Ah, damn it. You ordered some diff solo and to see if they work with your Falcon. Yeah, okay, that'd be interesting. I don't know actually. They could. Let's try that again. Yeah, this wire is kind of too big. And messed up now. That's as good as it's gonna get for now. They solved every problem I was having with two props that are far away. Oh, but are you using them in normal mode, so with a sender and receiver, or just a receiver with their differential stuff? They're better than the Falcon booster board. Okay. Interesting. Come on. You can do it. Okay, finally. It wasn't melting properly. Now it is. Okay. So, sender and receiver as a pair. Yeah, okay. So, this isn't pretty. But it's not touching. Ah, my light's broken. So, okay, 16 gauge is a, bit of a challenge. Okay. Oh, no. Damn it. Still too warm, I think. Or not enough solar, that's also an option. Oh. Ow, ow, ow. So let's put on some more solder. Okay. There. That should do. Use the flux. Yes. That wasn't the problem here. Okay, I don't think we have any bridged pads. No, we certainly don't have bridge pads because I spaced them that far apart. But, I mean, although there is now 16 gauge wire on there, I don't think that is what I would recommend. Let's see, let's do the pull test on the positives. Okay, that's attached. Pull test on the negatives. Okay, that's attached. Pull test on the data wires. Yep, okay. No flux were given. Nice, Monty. I'm glad you like him. Yeah, this is a bit but then in reality, so I think this wire is 22 or 24 gauge. In reality, I think we'd sell them with like 20 gauge or maybe 18 gauge, not 16 gauge. I don't know if there's cases for those yet, Monty. I designed them for, or I had them designed for the diff advanced. That's kind of, you know, an advantage of that system, I guess, that you get cases that I made. But I don't know if anyone designed them for the diff advanced yet. Sorry, diff solo yet. Okay, so now we have two soldered up. Okay, the arrows are pretty clear. That's good. How are the arrows? Okay, the arrow on the back is also pretty clear. So it's easy to see data in, data out. Data in, data out. VCC ground is also clear. You still haven't printed those new cases. What are you doing with your printers there, Draadstaal? I'm shocked. What is going on? I'm so shocked I need a drink. It's going to be font. No, it's going to be Sprite. Jet engine? What jet engine? As Dave Jones would say, that solar job is a bit, how are you doing? Yeah, I agree. Okay, let's clean up a little bit. Right, we need some Wagos. Some fake ass Wagos. Where are my straight through fake ass Wagos? There are some here. Put everything away. Oh, you're printing a jet engine. Interesting. I don't think there is one yet, Connor. I haven't seen one, at least on the Discord, so... So the idea with the loose wires is that I can just use some Wagos. Yeah, I get that. Cool. Yeah, that works. I guess on this side, whatever, I should put on some ferrules. For the Dig Quad, there's lots of models available, so I think you should just select the one that is best suited for your use case. Is it possible to post SAL files? STL? Yeah, sure. No problem. So, do we need the yellow ones? No. Then we need the black ones. We're almost out of the black ones. Oh no. And, oh, uh-oh. Okay. And an orange. There. Nope. Wrong tool. Okay. 20k. No, I still have bags and bags of those in stock. Although I'm not sure about the black ones. I think so. Once I figured out the ones I use a lot, I bought like 1,000 or even more. I don't remember, like a few thousand of the exact sizes I like, and like the yellow ones have been adding on for years. Still keep them in those boxes though. Cool. I'll check that at some point, Luke. Okay. Now, I guess we want to check this out somewhat, right? I guess we can do that. This is a dangerous pigtail, I think. Yes. Can anyone see what's wrong with this? What's wrong with the current picture? Let's not do that. I should have some pigtails here. Come on, I don't have any prepared pigtails here. That's impossible. I always find them when I don't need them, and then when I need them, they're not there. There. Yeah, reverse power, polarity, colors, it's all wrong. It's when you get working with certain vendors, and they're like, oh, we like to do it this way. And I'm like, no, we're not going to do it this way. The whole world does it another way. But you know, and no. Just no. Is it right now? No, it's still wrong. Oh. Try again. Try again. Try again. And that's how product development takes months. Am I gonna use... No, I'm not gonna use the JST one. Why am I doing this? What are you doing? See, this lines up a lot better. Yes, this is better. There's so many to choose from. Yeah, well, that's true. Let's do the little squishy trick. Cool, thanks, Luke. Always nice to hear that. Okay. So as you can see, you can fit 16 gauge into the Dig Quad or Dig Uno terminals. You just have to use the ferrules with the squishy trick. Yeah, there's special ways to navigate those, Emil. Luckily, I have a good partner there in AllNet. They help me with a lot of that stuff. Okay. So now we have something that is totally useless, because we have a Dig Quad, which has a bank of level shifters on there, and resistor selectors and everything. So this is totally useless, but it does allow us to test it and hook up a scope and see what the output says. And maybe the output says garbledy makes no sense. Well, then something is wrong. Yes, AN Penta Mini and also the new Dig Solo, even or the Diff Solo and the Diff Advance especially, and for instance the Dig Octa series, they all use rising clamp terminals. They're more expensive, but especially when fitting in bare wires or larger sizes, they're easier to work with. Sadly, for the Dig Quad design, I can't get them in the sizes I need them. And for the longest time, I've had issues with getting color-coded terminals. But that is now, I finally found a supplier which will do it for me on if I buy like 2,000 or 3,000, 5,000 for some colors, which is manageable with the size I am now. So that I can do color-coded terminals like on the AN Penta Mini. So red is positive, black negative, orange is both positive and negative but power related, and green generally is just GPIO, and then blue I use for level shifted outputs or digitally addressable. Yeah, you know. Stay tuned for the secret, and you'll see more of that. Okay, right. Let's hook this up. A really nice case. Which case are we talking about? Oh, the AN Penta Mini. Yes, that really came out nice. there's some issues I had with it, like these terminals are of course these terminals are of course bigger than the other ones, but I managed to get them to line up pretty well. And the silk screen is pretty clear now. Them a QT connector. And over here it's a bit of a hodgepodge because when you plug them in they're not the same height and things like that. But in the end I think it came out pretty well. And it's very clearly labeled and everything's clearly reachable and yeah. If you like that, stay tuned. Okay. So now we have this. Let's remove this guy. And let's get a scope. Because we can hook up some LEDs and see that the LEDs light up. But that doesn't really tell us, like, anything. Well, okay, it tells us a little bit. But as I started to mention, the current components on this board, I actually expect them not to work. So, we'll just do a quick test from that. And then, in the end, these are prototyping boards, which I will use to test different values of components to then determine what works best. Right? So, can we wiggle into... Oh. We might need some little wires, because this can't go into this enough. Yeah. So we want ground and data. Ground's black in this case. And data can be this guy. Nope. Good enough. Okay, let's get this out of the way. No, I do. So normally it has this, but then I have this. But it's okay. Because I can just connect these together. Easy. Yeah, China, man, China. And let's just connect this like so. And in theory, let's start up the scope. I guess we should do the... Oh, how am I gonna do that? I can't lie the scope on it on the back on its back because it has a power plug. Does that work? Let's see if that works. Let me prop this up. I need something to not make... Oh, I mean... I'll take it. This is shorting out. That's not good. There. Let's set this to 1 amp. Okay. That's fine. Ooh, what the hell's going on with my mouse? Okay. Find the IP the board got. 1024 1. Okay. 10. Nope. Okay, and I'm just setting it to a random pattern because it doesn't really matter. Let's hit the auto button. Nothing? Oh wait, did our little board light up? No, it doesn't. Oh, our little board didn't light up. Did I put the... Did I hook it up wrong? VCC gone. Okay, I did hook it up wrong. No, I hooked the board up to the out. I made this stupid mistake myself. I hooked up the out to the dig quad. I mean, how stupid can you be? Yeah, I need to physically reverse it. Oh. Well, these don't do anything in reverse. Why is the arrow there? Yeah, who knows? Whoever pays attention to that. Stupid. I mean... So can I get these Wagos in here? Let's see. I think enough. Well, you have to kind of squeeze them in there. But I think they'll make contact. So that's okay. Yeah. Yeah, exactly. So now we need more ferrules. Okay, this is annoying. There. But at least the LED isn't working, so that might already be an issue. But I probably just put it on backwards. And then we screw this in. Always check if it's aligned. Okay, let's get this one closer again. There. So now it is in the correct side. Great. Let's hook up this to positive. And this to a negative. Let's turn on power. Let's see. VCC. Ground. Yeah. Okay, still no LEDs, so that could be a problem. Now the power isn't directional, so this isn't going to fix our LED problem, but it might fix our not seeing anything on the scope problem. Oh wait. Oh, okay, well now we're starting to see something, but that doesn't look great. Let's, for fun, first check what we see coming from the board itself. Yeah, that's what I expect. Let's hit auto again. So this is coming from the level shifters on the board. Let's freeze that for a second. And as you can see here, we get a nice... oh, I didn't capture enough. Okay. We get nice up and down signals. I'm not sure if it's on 249 or 33R mode in this case. But we get a sloping start and then a nice clear finish. Later, Dave. So coming from the board, at least there is a good data signal. Right? It's pretty straight. I think these are on 249, so it's already slowed down a bit. That's why you get the sloping edge instead of a straight edge. And that is for EMI and other purposes. So now let's do the same thing from the data booster. Auto. So it sees something. Wait. But that certainly doesn't look right. So it's seeing zeros and ones, but then the peaks are all completely garbled. See that? And what voltage does that happen? 302. Okay. So let's quickly modify this one. I'm not going to do too much testing or troubleshooting today. I want to test two things. Let's first see if the diode is indeed reversed, or the what do you call it? The LED. Because I thought the bottom should be ground. And this should be positive. Yeah, it is. Did I think wrong? Did I just do it wrong? No, that wouldn't make any sense. Let me check. Where is it? Here. Oh, I'm an idiot. Okay. So this tiny little bugger here No, as I said, I expect this board to not work and have to shave and work with the components, but this LED here is on in reverse. So that's already something we know for sure. Oh my god. There. So that's something we need to fix. And then I want to take off the capacitor that's right next to that. So we're going to blast it with hot air. And I can't really do that on camera because it doesn't reach that far. Sorry, I'll zoom out, but... Yeah, no, you can't see it. Sorry. So I'm going to do that off camera real quick. Oh, need another socket. There. And I'm going to take off one of the capacitors and I'm going to reverse the LED. So 230 degrees, that should make it plenty hot. Okay, capacitor is off. Okay, I think that did it. Oh wait, huh? Oh, yeah, the LED is off. It's just not on the board anymore. Damn it. Now I'm not 100% sure if I reverse the LED in the end. I think so. We'll see. Some forced air cooling. I mean, it's really tiny mass, so it cools down really quickly. Okay, let's try that again. Let's power it on. Damn it! I probably reversed the LED twice. Okay, but let's see what taking off the capacitor did. Oh wait, there's no data signal yet. Okay. Interesting. What? Okay, let's do the multimeter like Philip has been asking. So ground and positive is 12 volt. Oh, other way around, but yep. Yep, 12 volt, and on the output wires it's also 12 volt. So that's fine. Auto. Oh. There we go. So this is still connected to the output side of the data booster, although my LED is still on wrong. So let's take a snapshot. Yeah, that's why I always mess them up too. But if we take a look at the output of the data booster now, that seems fine. Interesting, that actually seems more fine than I was expecting. Let me check something real quick. Oh, those are all on 249, okay. Yeah, those are all pretty good. Yeah, but I mean, what were we expecting? This thing is right behind the output of that thing, so I mean, nothing's really gonna happen, right? What we could do for fun is take. Oh. Take this 10 meters of wire, where we have a separate data wire and we have separate power wires, and I don't know, let's just hook that up. Well rolled up. This is like the worst case scenario. So we're extending power by 10 meters. And we're extending data by 10 meters. In separate, so not linked wire, but I'll put it in there. No, I need... Nah, it's more about what the data booster can do in itself. And if it can produce a, you know, workable signal for this distance. So let's give this a try real quick. Oh. Turn that on. So now there's all kinds of wires in between there after the data booster. And let's see what kind of signal it gets. Okay. 10 meters of wire? Bad. So let's see what happens. I mean, look at what happens. Remember, you know how I always talk about if you have data issues, run ground and the data signal next to each other. Look at what happens if I have this bundle of wire here, and then I put it in the bundle of wires here. I mean, this is totally garbled. Don't mind that. Right? That makes a big difference. Actually, what we can do is we can change stuff up. So, no. Oh, do I want to do that? I guess. I don't know. Anyway, this is messed up, but I kind of expected it to be messed up. Now let's change that. So let's remove this separate wire. Let's change it so that we only have data and ground, but on this coupled wire. Now it's still coiled up. You shouldn't do that either, but, you know. And let's make that our ground and data signal. Look at that. No, if it's corrupted like that, that's not going to fix it. But look at what just happened. We changed it from having positive, negative, and a separate data wire to having... well, we don't have positive right now, but that doesn't really influence anything. We now have ground and data running on a cable that's joined, so a two-wire cable. And let me show you a little bit closer. As you can see, although it's not perfect anymore, there's some capacitance there and things like that. As you can see now, the data signal is actually readable again, and this will work. Right? So let's see if you get a 1. Jesus. Oh, there we go. Okay. So there is some overshoot there, which goes to 5.92 volts. That's a bit high. And there is some undershoot, which goes to minus 1.24, 1.25. Yeah. But all in all, I mean, this will work. So that was the case like a few years back there, Fight Marine. But in the end, or over the years, we discovered that you can run that, but you need a different resistor to do that. And there is that type, or that resistor is on there. It says 33 ohm resistor. And then running bundled cable is actually better because you can get it, well, let's say 10 meters far without degrading as much if you have a separate cable. Now, running this separate cable, if we would have the 249 option, like on the Quad itself, would actually be better, and we'd probably get a usable signal. But in a lot of testing, running with ground and data together in 33R mode actually gives the best result, or the most reliable result, right? Now, this isn't perfect, but it's pretty good. So one of the things that's on here that wasn't on there before or normally is an ESD protection diode, because I wanted to experiment with having those on the data outputs, so that if a transient voltage happens, like during a lightning storm, etc., the outputs are protected. Because I might want to integrate that in my data boosters, or maybe in some upcoming boards. But at least that doesn't seem to have too much influence, so that's good. Now I do wonder what we would see if we measure right at the board. So let's do that. Okay, I need to figure this out. So I want some ground from here. Like that. And then I want... It's not completely what I would expect. Let's hit the setup real quick. Interesting. Why is it so garbled? Maybe because my ground sucks. Let's try that again. Oh. Yeah, so this is coming from the Quad. That's very nice. This is not great. Not sure why. Yeah, so perfect data signal, right? Very clean. Oh, I know why. I'm an idiot. Let me guess. Now it's fine. Yep, there we go. Okay. Yeah, so having those wires connected but not having anything on them in the end basically makes them giant antennas and capacity loaded, and it completely messes with the data signal. Even if we measure it right here, not at the end of the cable, yeah. So... But, I mean, this test is slightly useless, because this is the incoming signal, which is already 5.2-ish at the top end. And then this is also 5.2 is at the top end, because it's not really doing anything, because, well, you know, there's nothing to do. Data debooster. Yeah, no, but having loose wires connected that don't do anything, that are not connected to another device, can totally mess it up. Yeah. Yeah, running data and ground together basically couples it in a transmission line effect, and combined with the correct resistors and data drivers, which are on my boards, makes it so you can get the data signal very far.
Think I need an exorcist right.
Do you have a resistor on there, Fight Marine? And what do you have, a 2-wire cable and separate data, or do you have a 3-wire cable? And do you have a correct level shifter? That's also important. I mean, yeah, you need the correct level shifting chip. And then you get a really clean signal like this. Yeah, that's pretty good. The live ends are going to short together. Oh, you mean these? Yeah, maybe. Maybe. Thanks. Okay, well, as I said, this is a testing board, although it's also a product kind of that I want to release in the future. So I want to have a smaller data booster board, kind of like this, but I want to have some extra protection circuits on there and maybe shape the data signal just a little bit different. And that's what I'm testing with these boards. That's why I made 3 now, so I can change the values and components on them, and then test them with 5-meter cable, 10-meter cable, separate data wire, linked data wire, etc., etc., and figure out something that works well in all situations, but you know, is also nicely EMI compliant and protects better protects for like lightning strikes or anything else like that. Yeah. Yeah, I mean, the reason why I sold a 16 gauge to this guy is because I want to test the throughput. Like if I put 5 amps through there, how warm will they get? And then it's better to have nice thick wires. So a 74 HCT 125N should be perfect. And if you have a 3-wire cable, so 3 wires together with ground and data close for the whole length, if you use a 33 ohm resistor, that should be perfect. Secret time, yeah, because I'm getting tired. Let's turn this off. Let's turn that off. Okay. This will, I will be testing that some other time. Cool. Well, except for the LED, at least it worked, right? So we were talking about color-coded terminals, and I got something in today. The housing is still a little bit the wrong color. You've seen this housing before probably, but it's supposed to be black, and this is dark gray. But we couldn't get black samples in time, so I was like, okay, just send me dark gray ones, I'll take a look at those. 10 plus 22. Then maybe try something like 50 or 60 ohm. Anyway, so this is dark gray, but I think I like black better. But this is an Quinled, really? Quinled AN Deca Plus. So we have an external antenna connector here. and it's a 5-channel high-power analog dimmer plus digital. So let me go through the ports. We have USB-C, and we have a stemma QT for I2C connector. Then we have Ethernet. We again have 3 button pins, ground and 3.3 volts, so you can connect buttons, etc. And we have some nice beefy power input terminals, and these are pluggable sockets. Now I don't know if I have those on my disk. No, I don't. So that is the front side, I guess we could say. Really. And the back side has all the outputs. So we have positive outputs, which are internally fused. Then we have another set of positive outputs, which are internally fused. And then we have another switched output, which is also internally fused. And then we have 5 dimming channels, L1, L2, 3, 4, and 5. And L1 and L2 are set up as having the same channel on one plug on the output. Do I have it here? So, yeah, if you have one of these pluggable outputs like so. Camera doesn't like focusing. Come on. There. You can use this for power injection because this has high power output channels of up to 10 amps each. Now, I rate the board for 30 amps total, but that's why you have 2, well, they're all the same high power capable channels, but these 2 basically have the power injection function. So if you're running RGB plus CCT, you can have the whites on the injectable outputs and then RGB on here, for instance, or however you want to do it. Then we have a special connector here. That is for a buck converter. Let's see, I think I have it here. You can pick up a buck converter like this and just plug it in like that. And let's say you are you have a 24 volt power supply. This then comes out and comes back as, well, in this case, it's 12 to 24 volt in, 5 volt 10 amps out. So that goes back into the board, into a capacitor. And then we have a separate output here for digital LEDs up to 48 volt and internally fused, etc. So you can run 24 or even 48 volt analog LEDs while also running 5 volt digitally addressable LEDs on the same controller. So this is basically the first hybrid controller in that sense, right? Yeah, that's kind of the AN Penta Mini. It has, or in the AN Deca Plus. Wait, AN Deca? Did I make a mistake? I think I was sleeping that day. My... Oh, it's good to make prototypes. Oh my god. I got my own name wrong. I knew I made these on a day I was having a massive headache. I was like, I just need to get it done. It's supposed to be an AN Penta Mini and an AN Penta Plus. But now we have an AN Deca Plus, which makes no sense. Oh man, I'm so stupid. Okay. Well, we'll fix that. No. There is going to be an AN Penta Deca. But okay. Yeah, so even I got confused, Andy. Okay, so this will be the AN Penta Plus. But currently it's called the AN Deca Plus. Which makes no sense because there's not 10 channels on here. But that's okay. Yeah, I like how the silk screen has come out. And even if you plug in the connector, you can still read on the bottom what it is or on the top. We've got these nice speed holes for the venting. That's also good. Yeah, we can still fix that. That's no problem.
They talk about another kind of world.
Do we have some of these connectors? I want to show off the connectors. I need to distract you guys. Hold on. Hold on. The bag emptied in the box. So we actually went through various connectors for this board. Yeah, exactly. The magic smoke can escape there. That's a good way of describing it. We went through various connectors for this board, but in the end they all had issues or I didn't like them, etc. So we settled on these, and these are 7.62 millimeters pluggable. So on the Power 7 for the Dig Octa, we also have 7.62 millimeter connectors, but they're not pluggable, and these are. And I kind of wanted to stick with the whole. Well, this isn't the right one, but it'll fit. The whole pluggable connector type deal here. They stick out a lot, but in the end, I found that was the best compromise, really. So the back has these 5.08 millimeter ones, like so. And, well, as I was saying earlier, if you order enough of them, you can get them color-coded. So I kind of went in deep, and I even got these big ones color-coded. So, of course, it's immediately obvious that this is positive and this is ground. And the same on the back, what's positive, what's ground, etc. Right? These will take 12 gauge with ferrule or 10 gauge without ferrule, I believe. So that is plenty to get 30 amps in there. Yeah. And they couple really nice with a UHP power supply from Meanwhile, for instance, and then everything is dead silent. Very cool. I'm gonna take. So we took a look inside. I haven't looked in. I got these in today, so I literally haven't looked at them yet. As you obviously just saw with the stupid name. Let's get them open and take a look inside. Yeah, and this is the first hybrid board, so you can do analog for whites, for instance, and RGB for digital and addressable. Yeah, I feel the end product came out a bit big, especially if you compare it to the AN Penta Mini. I mean, these basically, these are both 5-channel analog dimmers. This one just does 3 times the power and has power injection and the digital feature, etc. And that just takes up space on the outside. So even if I could make the circuit on the inside smaller, you'd still need the room for the ports, right? So sometimes I'm like, why didn't I make it smaller? And then I'm like, but if I make it smaller, where am I going to put the ports? And then I generally rather go for function than design. Although these look nice, so. Yeah. Okay, let's take a look inside. I shouldn't have to remove the board. I can just pop open the cover. Do I have to remove? Oh, I didn't need to unscrew the bottom ones. Okay. But as you can see, I mean, even as it is, this PCB is pretty full. Right? Later, Nigel. I did write it correct on the board itself. AM Penta Plus. Yeah, I mean, worst case, we'll sell them with gray cases. Worst case, haha. But I really like my black cases, so if I can make that happen, I'll make that happen. But yeah. Yeah, soldering job looks great. And of course, there were other little things, like I wrote on the PCB, one 7.5 amp fuse max, but there's 8 amp fuses on there. It's because there were no 7.5 amp fuses. But that's all things we figure out during either prototyping or first production run. That's fine. Philip will take him, yeah. A little bit low on solder here. Yeah, maybe. This looks like it. Okay. Anyway, I'll take a look at that more later on. So let's pop the cover on again and screw it all back. There's some other minor changes I already want to make that we learned during the first production run, so. But that's always how it goes, that's fine. ETA, I'd say a few weeks. I'm hoping 2 weeks, maybe 3. I'm trying to get the documentation done and the testers built and the firmware in order, stuff like that. Yeah, ESP Home and WLED should support it perfectly, yes. Okay, plates fit good. I did a lot of testing to get all the spacing and stuff like that correct. So I have to check how many faceplates we made. If it was a test run, you know, I'll fix it. If it wasn't a test run, I don't know yet. It's, you know, kind of wasteful to throw away a few hundred PCBs, or, well, faceplates, if it's just the wrong name on there. So, who knows? Maybe we'll have a first edition. And PCBs are cheap, but, you know. Yeah, and I picked this case because it has nice mounting holes. So you can easily mount it down to a board. Yeah. Actually, Philip, I was thinking about that recently, and I have kept everything. So, lots of prototypes and things like that. And let's talk about that again sometime. But I figured you were busy with the house, your house anyway, so... Founder Edition, who knows? We'll just put a sticker over it. No, I wouldn't put a sticker over it. I just leave it as is. And then include a note like, yeah, first production batch, I had a headache that day. And My God, how stupid. Funny thing is, I'm not the first one this went through hands. It went through. Nobody else noticed. Oh, okay. Well, anyway. That is something we're still discussing. We don't produce those that often, so they're just stocked, and you know. Cool. Well, kitchen in would be nice. A free black Sharpie. I can't read the text there. Yeah. You know, stuff happens. Okay. Well, that was the secret for today. These are coming, whatever they're called. I will be doing my testing on this version. We have a few hundred produced, but we still need to figure out casing, website, naming, and testing, firmware, stuff like that. But we'll be doing that over the next few weeks. And, well, then at some point you will see an announcement video. I'm gonna cut out for today. It's already been 3 hours again, so I thank you all very much for watching me stumble through soldering these little guys. In the end, I mean, it worked. So we still had the LED reversed, but that's a small thing. As I said, these are meant for prototyping, so I will be doing testing with that to tune and, you know, alter the output stages for the level shifters. And then at some point, once I figure it all out, there will probably be improvements to come to the boards, and this might become a product. So we'll see about that. Thanks for hanging out, and you have to stay long. I'm not done yet. That's too bad, Emil. Thanks for being here and hanging out with me, and I'll see you guys in the next video, next live stream, in the comments, or on the Discord server. Bye-bye.
When did we both get so still? Tell me something real. I need a new diamond shot. Make me feel what I forgot. Baby, got the will. We are road warriors, free and notorious. Shut up and drive. Ride or die till the end. For it, kiss me again. Shut up and drive.